All right, in this video we're going to talk about an introduction to what's called R3, or three-dimensional coordinate system. So you may have seen this symbol before in math classes, probably not with the 3 there though. So you may have seen this symbol. A lot of students know what that means, and they've seen that maybe when you deal with solving equations or talking about the domain of a function or something like that, and they'll talk about this as all real numbers. So really this is the set of all real numbers. Sometimes we might write that other ways too. Visually we might write that as a number line. So sometimes we represent that as a number line. We talk about that as the continuum, or we might write an interval, something like -infinity to infinity. So these are kind of all different ways of visualizing and thinking about what R is. And then you probably, maybe you've seen this before, you may or may not have called it this, but thinking about what's called R2. So going to the kind of visual representation here of thinking about the number line, R2, you could think about that like 2 number lines. We usually put those intersecting at a right angle. The horizontal one is our x-axis, and the vertical one is our y-axis. And we have all sorts of conventions about that. We can think about points in here, x, y points. We know that the first number is the x and the second one is the y, and you can plot points. You can talk about the origin. You can talk about axes, quadrants. So we're going to extend that idea to R3. Another way to think about R2 in terms of thinking about sets is to think about, I'm going to use some set notation here for R2, the set of all xy, so ordered pairs xy, where x, I'll put such that, so colon here, where x is an element of the real numbers and y is an element of the real numbers. So this is using some kind of fancy math notation here, but this is set notation, the set of all xy, such that x is in the real numbers and y is in the real numbers. So it's just a set notation way of writing what we've described here. All right, so for R3, which is what we really want to talk about here, we can think about R3 in the same way, and we're going to kind of start with the visual idea here. So we can think about that in terms of 3 number lines, all intersecting at right angles. And so you've got one going up and down, one going left and right, and then that third one would be coming out of the surface. So draw that like that, where that would be coming out of the surface here. There are some conventions about which one we label x and y and z. Just like we know here, if we don't see labels, we would know that the positive x-axis is to the right and the positive y-axis is up, even if we didn't see labels there. And these are maybe a little different than some students maybe think they should be. And depending on the application, you might have them labeled differently. In mathematics, we usually put the positive z-axis going up. The positive y-axis is generally to the right. And the positive x-axis is the one that's coming out of the paper. So there are some reasons for that. In computer graphics, often the x and y axes are as usual, and the z-axis would be coming out of the surface. That way, if you don't need z, then your x and y are as usual. Why we in math do it this way has to do with function ideas and thinking about z as a function of x and y. It's like you might think about y as a function of x, and thinking about things like max and min values so that things look like you're kind of used to thinking about when you think about maximum and minimum values. So just like with the x and y coordinate system, you can turn those axes around and label them differently if you want. And the same with this. I have a model here that I just made out of sticks. It's pretty easy to make one for yourself. You can make fancier models too, but I just made this one out of some skewers, bamboo skewers that I just got at the grocery store, and tape and cardboard. So you don't need to make one, but it can be helpful to have one to think about. I made my z-axis zebra striped. I just took a marker and drew on it. My y-axis is yellow, and my x-axis is red. And so they're all intersecting at 90-degree angles here. And so you can kind of think about your coordinate system like that. So your z-axis would be up, your positive y-axis to the right, and your positive x-axis coming out. And one of the things to think about is that as things turn, as you turn kind of your eye, or as you raise and lower your viewing eye, things look different here, right? So if you have your axes kind of oriented like this, then it looks sort of like what I've drawn over here. But if I turn that a little bit, then maybe it looks like the x and y axes are both coming out of the surface of the paper. I can turn that some more, and it looks like now the x-axis is in the, or the y-axis is in the surface of the paper, and the x-axis is coming out. So we can turn that in lots of different directions. I can even turn it upside down so that if I want the positive z-axis to be going down, I can have that. I can turn it lots of different directions. But one important thing here is that we want to maintain what's called a right-handed coordinate system, so that you're keeping the axes in this orientation to each other. And so if you're moving it, it's in a rigid motion. You can't just pick up one of the axes and flip it without affecting how you've changed these other axes. Otherwise, some properties that we'll talk about when we get to vectors and things like that that you might think you know won't remain true if you don't maintain this right-handed coordinate system. So we'll talk about that some more when we do some other things. But I'm just going to go over here and talk some more about some specific vocabulary here. So I've drawn an XYZ coordinate system. If we want to think about in terms of set notation here, we could talk about R3 as the set of all XYZ ordered triples, where X, Y, and Z are all elements of the real numbers. So I use slightly different notation here for that one, but the same idea here, X, Y, and Z all in the set of real numbers. And just like for an XY coordinate system, we have some standard vocabulary that we talk about. We can talk about the origin would be the point where all of the coordinate axes intersect. And so that would be the ordered triple where X, Y, and Z are all zeros. In the XY coordinate system, you often talk about quadrants, and there are specific ways of labeling those quadrants. In a 3D coordinate system, you've got octants instead of quadrants. And there's not a standard way to number all of them, but there is one that we specifically number. The first octant is where X, Y, and Z are all positive. And that goes along with thinking about the first quadrant being where X and Y would both be positive in an XY coordinate system. So the first octant would be where X, Y, and Z are all greater than 0. Greater than 0, not greater than or equal to 0. So that would be this part here where I have my positive Z, positive X, and positive Y axes. We also talk about things that, we can talk about the coordinate axes, the x-axis, y-axis, and z-axis, but also what are called the coordinate planes. And so there are really 3 coordinate planes. We've got the one that's really in the surface of my board here, surface of the screen, the YZ plane. And so that would be the plane containing the Y and Z axes, and that would be where X is 0. We've got an XY plane, be kind of like the floor of this region here, of that first octant, where that would be the plane containing the X and Y axes, and that would be where Z is 0. And then the XZ plane, I'll just draw a little sketch here, where that XZ plane would be. XZ plane, that would be just a part of the XZ plane containing the X and Z axes that would be coming out of the surface of the screen here, parallel to the X and Z axes, so really going back in all those regions. And that would be where the Y coordinates are 0. All right, we're going to do some things in the next couple videos about plotting points, doing some calculations with points, some of the same things that you did in algebra when you first learned about plotting points in an XY coordinate system. We'll just be extending that to 3 dimensions.